Today we're going to start looking at some totally different types of equations from what you guys are used to. So what you're used to is having a y equals and putting in the variable x, and you look at how x affects y as x changes. But today we're starting with parametric equations, which is the first new type of equation that we're going to be looking at in this unit. And in parametric equations, x and y are going to act completely independently of each other. So if you change x, that doesn't necessarily change what happens to y. Instead, we're going to have a new variable. It's going to be t, and it represents time. And it's called a parameter, and what we're looking at is how x and y change separately over time. So we're going to start exploring that a little bit today. The first thing I really want you guys to notice is that I have screenshots from a TI-84 calculator, which is what we'll be using in class if we were in class, over here on the right. So basically on your calculator, you would go to mode, and instead of being in your regular function mode right here that we're normally in, you would just change it to parametric mode. It's PAR. And then it gives you an x equation and a y equation. And you just type in the equation with the variable t for both x and y. However, we're not in class, so I'm going to be using an online software tool to be doing that instead. So this is the website that I'm going to be using, and I've linked it in your weekly assignment calendar as well. It's called graphsketch.com, and it's the parametric version. So I think on our PowerPoint that we had our two equations, and if you scroll down, you can see that you have an x and a y equation. So we had 5t, and I think it was 10 minus 16t squared. So let me get those two in there. And then I'm going to come over here, and it gives us an x range and a y range. For now, I'm going to leave those alone. But my t range, remember, t is representing time. So I'm just going to set the minimum for the t range to 0. And then to get it to actually graph, you just have to click plot. And you can see here that it's plotting starting at time equals 0, and it just kind of makes an upside down parabola. So it doesn't necessarily look different than the graphs that you're used to. It just might behave a little differently, which is what we're going to look at. If we were in class, I'd be giving you guys this sheet here as a worksheet, and everyone would be doing it right now. So if you want to play along, then feel free to pause the video and jot this down on your paper. Otherwise, just kind of watch what I'm doing here. I just want to give you a good introduction to parametric equations so you really understand what's going on. So in this example, we have that x is the square root of t and y is 2 minus t. So it gives us the t value right here, and it wants us to fill in the table for x and y. So if x is the square root of t, then the first number that you need is the square root of 0, which is 0, and then the square root of 1, which is 1. I'll finish filling in some of these other harder ones later in a second, and then come back to you guys. I can go ahead and do the square root of 4. I do know that one. And then for the y values, we have that y is 2 minus t, so I would be doing y equals 2 minus 0, which is 2, 2 minus 1, which is 1, 2 minus 2, which is 0, and so on for those. And then the next step is that you're going to want to plot the points from part A. So I'm going to pause here and finish filling in my table and plot the points, and then I will get back with you guys in a second. Okay, I lied. I'm actually going to make us go ahead and graph it together too. So I realized it says plot the points x and y. So yes, we do have this other variable t, but whenever we're plotting the points, we're not necessarily going to worry about that right now. We just have points that have an x value and a y value. So the first point that I'm going to plot is going to be 0, 2. I'm going to move on and plot 1, 1. 1.410, and so on. So my graph is still going to be just a regular like XY plane. The X is the horizontal, Y is vertical. You guys have done that for a long time. So we're going to go ahead and plot the points. 0, 2 is there. 1, 1 goes here. And then it's like 1.410. That's a little weird. 1.41 is somewhere around here, and we hit 0. 1.73, we go down to -1, and 2, we go down to -2. So we have this kind of weird action happening like this here. The next thing that it wants us to do is to use a graphing utility, which would normally be your calculator, to graph the curve represented by these parametric equations. But since we don't have your calculators, I went ahead and came over here to graphsketch.com. And I already entered the equations over here for x and y for us. I also changed my x range and my y range to match more of what we have already. And I'm going to hit plot. And it gives us essentially the same graph that we got. So that is what you would want it to look like. Okay, last part, and arguably definitely the most important part of this whole experience in this problem here, is we want to find the rectangular equation. And the rectangular equation literally just means the y equals something equation, or put it in terms of x and y. And to do that, we have to eliminate the parameter. So that means we're getting rid of t. And then it wants us to sketch the graph. Okay, that's fine. So basically, to get rid of t, we need to solve for t in one of the equations and then replace t in the other equation. So basically, I'm going to come here and I'm going to solve for t in this equation. So right now, I have x equals the square root of t. And if I wanted to solve for t in that, I would need to get rid of the square root sign. So I'm just going to square both sides. So now the square root and the square on this side are going to cancel, and we're going to have t, and it's going to be equal to x squared. So then I want to take that t equals x squared here and replace the t in this equation with x squared. So now we would have y equals 2 minus x squared as our rectangular equation. So now to sketch our rectangular equation, 2 minus x squared, I'm no longer going to use graphsketch.com because it's no longer parametric. So instead, I'm just going to use Desmos, and I'm going to have y equals 2 minus x squared. And you can see we get the same little upside down parabola. One of the main differences that you should notice here is in our rectangular equation, we don't have that limitation of time starting at 0. So you get the left side of the parabola as well, and it keeps going forever. And in parametric, if the time kept going forever, which typically there would be some kind of restriction on it to prevent that from happening, then in theory, this could keep going down forever. But the biggest difference is going to be just the domain of this graph. This one is going to be from -infinity to infinity. In the parametric version, it would be limited. It wouldn't start until we were at x equals 0. And then based on how long the time went on, it may stop over at 2 or some other place. So that brings us to the main thing that we need to know how to do for parametric equations, and that is eliminating the parameter. So now's a really good time. Hit pause, take these notes down, and then we'll get back to this whenever you're ready. So basically, we need to solve for t in one of the equations. I prefer to solve for t in the x equation so that I can put that into the y equals equation just because that's more like what we're used to. So we're going to solve for t in the x equation. So we start with x equals t squared minus 4. So the first thing you're going to do is add 4 to both sides, and you would have x plus 4 equals t squared. And then you're just going to take the square root to get rid of that squared on the t, and you would have the square root of x plus 4 equals t. So then to put it in the rectangular form, I need to take that t equals x plus 4 and replace the t in the y equation. So I would have y equals the square root of x plus 4 divided by 2. And that would be my new rectangular equation. Now my suggestion would be to double check and make sure that these are the same equations. So take your parametric equations and enter it either on parametric mode on your calculator or in graphsketch.com. Then take your rectangular and enter it in function mode or on Desmos. And so I went ahead and entered the equations on both. So this is my rectangular equation. It's on Desmos. It's a square root equation and starts at -4 and goes on. And then I'm going to come over to Graph Sketch. And here's my parametric equation. So you can see that the top of the graph is the same. The only difference is being in parametric mode. It doesn't have to be a function. So it graphs this bottom half as well. The Desmos does not graph the negative half of that square root equation. A square root equation is kind of like a sideways parabola, but since this is graphing it as a function, it's only going to graph the top half, but the parametric version is going to graph both the bottom and top half of that kind of sideways parabola. So now all that's left to do is just kind of practice these a bit. So I fear that this video is already getting kind of long, so I'm not going to do all of the practice problems I would normally do in class. The first one's really easy. We're going to skip that one. The second one's pretty easy too, but let's go ahead and do it. So I'm going to solve for t in the x equation. So all I have to do is get rid of the square root. So I'm going to have t is the square root of x. And then I need to put the square root of x into the t in the y equation. So I'm going to get y equals the square root of x minus 2. Obviously, this next one is a little bit more tricky. So I'm going to start with my x equation is 1 over the square root of t plus 1. So the first thing that we need to do is get that t out of the denominator position. So we're going to basically just cross multiply. So we'll multiply that square root of t thing over to the other side. So I'm going to have x times the square root of t plus 1 equals to 1. And now I need to get rid of the x on that side with the t. So I'm going to divide by x on both sides. Now I'd have the square root of t plus 1 equals 1 over x. So next step is to get rid of the square root. So I'm going to square both sides. So I would have t plus 1 equals 1 over x squared, which if you actually square that out, it would just be 1 over x squared. And so t plus 1 equals 1 over x squared. So we need to subtract 1 from both sides. You're going to get t equals 1 over x squared minus 1. So then that's already pretty ugly, but now I have to put it back into the y equation everywhere that you have a t. So basically, we're going to put in y equals 1 over x squared minus 1 divided by 1 over x squared minus 1 plus 1. So that's a little crazy. The first thing that I noticed that we can do is get rid of that minus 1 plus 1. Those are going to cancel each other out. So now we have 1 over x squared minus 1 over 1 over x squared. Again, this is pretty ugly. Let me insert a new page here so that we can play with that a little bit. So as of right now, we have 1 over x squared minus 1 over 1 over x squared. I don't want any of that stuff there, but anyway. Okay, so whenever I see something over a fraction, I see it as dividing by a fraction. So when you divide by a fraction, that's the same as multiplying by the reciprocal. So now I'm going to want to multiply that by x squared over 1. that's essentially the same thing that we're doing. That is going to cancel out this denominator, and x squared over 1 is just going to become x squared. And now we need to essentially just distribute that x squared into the numerator. So I would have x squared times 1 over x squared minus 1. X squared times 1 over x squared is going to be x squared over x squared. And then minus 1 times x squared. And so then x squared over x squared is going to become 1 minus x squared. And so we would have y equals 1 minus x squared. So that took a really long time to get to. It became pretty ugly at times, but that is one way to eliminate that parameter. Also, sorry that I didn't insert a blank slide and that this looks pretty ugly right now, but there would be your answer. So just so you guys could see this on a graph as well, I went ahead and plotted it in both parametric and rectangular on Graph Sketch and Desmos. So in the parametric, because there's a square root in that equation, it's not going to do the left-hand side of that parabola, but you still get a parabola that is negative and shifted up 1. On Desmos, you get the same parabola, but since the domain is not restricted on Desmos, you're going to go ahead and get that whole parabola instead of just the half that you get in parametric mode. So just watch out for that too. So I'm going to go ahead and end this video here. The big takeaways that I want you guys to get from this is try to just wrap your mind around this new type of equation that creates this new type of graph where x and y are acting completely independently, and you have this new variable t. It's a parameter and it just represents time. So you're just looking at how x and y are acting independently over time, but it's being graphed all together on one graph. And also just try to remember how to eliminate the parameter. So basically just solve for t in one of the equations. I typically solve for t in the x equation, and then whatever new equation you get when you do that, just plug that in for t in the second equation and simplify. So try to practice on the assignment for today, and if you have any questions, please just let me know. Last thing, I forgot to say this, the reason you would eliminate the parameter is if you're trying to rewrite a parametric equation in rectangular form. So that's the time that you're going to want to eliminate that parameter, is if you're faced with something where it says rewrite these two parametric equations in rectangular form. So that is it. I hope you guys have a great rest of your day.